Okay, I'm going to be talking about projectile motion, and you have a quiz on Friday. The formula for a freely falling object, ignoring air resistance, is given as below. Now, the reason we get to ignore air resistance is because we're talking about it as a theoretical instance. If you're doing a job like aerospace engineering and you're talking about a plane, you're not allowed to ignore air resistance. That's important. But in our intents and purposes, we can ignore it. So it's h of t equals negative 16t squared plus v naught t, that little subscript of 0 means naught, v naught t plus h naught t. Memorize this. So h of t represents the object's height at any time t measured in feet. V naught represents the initial velocity of the object measured in feet per second, and velocity means speed. And h naught represents the initial height of the object measured in feet. So in v naught you have initial velocity, and in h naught you have initial height. Initial means the beginning. What is the velocity you started with? What is the height you started with? All right, so Nora hits a softball straight up with a speed of 120 feet per second. Her bat contacts the ball at a height of 3 feet above the ground. How long will it be until the ball hits the ground? What is the maximum height of the ball? When does the ball reach the maximum height? So I have multiple questions. Well, first I need to write my quadratic. So I have h of t equals negative 16t squared plus my initial velocity, which is 112t, plus my initial height, which is 3. All right, so how long will it be until the ball hits the ground? So if I'm on the ground, my height, my final height is 0. So I set this equal to 0. So 0 equals negative 16t squared plus 112t plus 3. So I'm going to put this in my calculator. Alright, and I told you if it's set equal to 0, then you have to find the zeros. So trace 36, and I can't really see it well, so I'm going to zoom out. That didn't help me much. Here we go. So zoom 0 is what helped me a lot. Now, if you look at this, it crosses the x-axis twice. It crosses it right here, and it crosses it right here. Now, when it crosses it here, that answer doesn't make any sense because I wasn't on the ground. I only hit the ground once. I hit it from a height of 3 feet. So it only hits the ground one time. So I need to find this answer. So second, trace 0, and use your diagram to figure out where left bound and right bound are. Left bound is above, and right bound is below. So it takes 7.5 seconds to reach the ground. Okay, so now I need to answer, what is the maximum height of the ball? First I need to move all this other junk out of my way. Alright, what is the maximum height of the ball? So now I'm going to find the maximum, just like you're used to doing. So second trace, maximum. Left bound is on the left. Right bound is on the right. And your maximum is 3.75. Because it says, oh, Miss Golden answered the wrong question. It said, what is the maximum height of the ball? maximum height of the ball is y. So the maximum height of the ball is 228. Max height is 228 feet. Then it says, when does the ball reach the maximum height? And when is the x, and that is 3.75 seconds. All right. So the only new thing there was incorporating that equation. So now let's move on. All right, so Joe throws an apple with an initial upward velocity of 88 feet per second from a height of 3 feet. When will the apple be 25 feet above the ground? When will the apple reach 200 feet? What is the maximum height of the apple? At what time does the apple reach maximum height? When will the apple hit the ground? So I have multiple questions, so I'm going to number them. Help me keep up with it. When will the apple reach 24 feet? That's question 1. When will the apple reach 200 feet? That's question 2. What is the maximum height of the apple? That's question 3. At what time does the apple reach maximum height? Question 4. And when will the apple hit the ground? Question 5. All right, so I'm on question 1. When will the apple be 24 feet above the ground? Well, first of all, I need to come up with my equation. So h of t equals negative 16t squared plus your initial velocity, which is 88t, plus your initial height, which is 3 feet. Okay, so I want to know when will it be 24 feet above the ground, so that's h of t. So 24 equals negative 16t squared plus 88t plus 3. And you have to get the t, you have to get it equal to 0, so you need to subtract 24 on both sides. So 0 equals negative 16t squared plus 88t minus 21. Where did I get that from? I subtracted 24 on both sides. Okay, now I have it equal to 0, so I need to find the answer in my calculator. When it's equal to 0, you find the zeros. So, negative 16x squared plus 88x minus 21 to 6. Okay, and we can't see it very well. You can see it, but it's not very well. So I'm going to zoom 0. All right, now you can see it nicely. Now this time there are 2 answers, because when you throw the ball up from 3 feet, it hits 24 feet on the way up, and then on its way back down, it hits 24 feet again. So I do have 2 answers. So I do need to find this one and that one. So I'm finding my zeros twice. I'm starting with this one over here. So you are below and above, and if you're struggling with that, then memorize your diagram. So the first time it reaches 24 feet is at 0.25 seconds. And the second time it reaches 24 feet is second trace 0. And this time you're finding the one on the right. You have to be above, below. If you're having trouble with that, use your diagram I gave you. And the second time is at 5.25 seconds. So on the way up, it hit it after 0.25 seconds, and then on the apple's way down, it hit at 5.25 seconds. All right, when will the apple reach 200 feet? All right, well, let's figure that out. This time I need to set it equal to 200. So 200 equals negative 16t squared plus 88t plus 3. And you need to subtract 200 on both sides. So 0 equals negative 16t squared plus 88t minus 197. All right, so now I need to do my 0 thing again. So I go in my calculator I just need to change this end because the rest is the same. So it's minus 197. All right, then you press zoom 6. And then you press zoom 0. And if you notice, it doesn't really cross over the x-axis. And because it doesn't cross over the x-axis, that means it doesn't reach a height of 200 feet. It doesn't. Because it doesn't cross over the x-axis. All right, so now I'm moving on to question 3. Question 3 says, what is the maximum height of the apple? So now it wants to find the maximum height. Now something that's very important is you have manipulated this. You have changed it. You set it equal to 200. So when you find the maximum height, you have to use the original. And that is h of t equals negative 16t squared plus 88t plus 3. That's what I started with. That's what you have to use when finding maximums and minimums. You must use the original. So go in your calculator and clear it out. And negative 16x squared plus 88x plus 3. And I want to find the maximum, so zoom 6. Then zoom 0. I'm finding the max, so that's second trace 4. Enter, and then over here, enter, and your maximum height is 124 feet. 124. All right, and then it wants to know what is the time, at what time does the apple reach the maximum height? The question 4 is at what time? And the time was 2.75 seconds. And my last question is, when does the apple hit the ground? Question 5 is, when does it hit the ground? Well, if it hits the ground, then your final height is 0 because you're chilling on the ground, so your height is 0. And I go back in my calculator. And I find where it crosses the x-axis. The second trace, 0, maybe above, and then below. And then your answer is 5.53 seconds. It will be on the ground. All right. Make sure you bring your stuff for the lab tomorrow, and you have a quiz on Friday.